Alright, today we're going to talk about conditions for special parallelograms. Yesterday we talked about some of the properties of them. Now we're going to talk about some of the conditions. What were some of the special parallelograms we talked about yesterday? Rectangles was one of them. What's another one? Rhombus. And the third one was a square. A rectangle. What was one of the properties of a rectangle? All what?
Right angles.
All right angles, yeah. What was one of the properties of a rhombus?
They're all the same.
All the same, yeah. All sides are the same. And then what about a square?
And all the sides are the same.
All the sides are the same, all the angles are the same. Nice job. So that's conditions for special parallelograms, section 6.5. You can use the following conditions to determine whether a parallelogram is a rectangle. Now, these conditions can only be used if you know it's a parallelogram here. Okay? So, if one angle is a right angle, then JKLM is a rectangle. So, if you know it's a parallelogram and one of the angles is a right angle, then we know it's going to be a rectangle. Why? Because if M is 90 degrees, L has to be 90 degrees, which means J has to be 90 degrees, which means K has to be 90 degrees, based on the properties of parallel lines and all those different parts. Okay? Which is true. If the diagonals of if the diagonals are congruent, then it's a rectangle. So if you have this, and if the diagonals are congruent, then the following shape is a rectangle. And then you can use the following conditions to determine whether a parallelogram is a rhombus. You can use the following ones to determine whether it's a rhombus. If one pair of consecutive sides are congruent, then it's a rhombus. Okay? And again, this is only true if you know it's a parallelogram. For example, I can have two sides being congruent, and then I could have, something like that, where they're not going to be the same. Okay, so recognize it has to be a parallelogram first. If the diagonals are perpendicular, this is one we struggled with yesterday a little bit. If the diagonals are perpendicular, so that means they form right angles in there, then it's a rhombus. And if one diagonal bisects, what's it mean to bisect? Cut in half. So if one diagonal bisects a pair of opposite angles, then TUVW is a rhombus. So using those conditions, let's look at these first two. Determine whether the conclusion is valid. If not, tell what additional information is needed to make it valid. So first, number one, is EFGH a rectangle? Chris, what do you say?
Yes.
Yes. Why do you know that?
Because F and G and H are parallel.
Yep, we have parallel sides. So parallel sides tell me it's a parallelogram right away.
And then it has a right angle in it.
So parallel sides, and then we have a right angle. Yes, it has to be a rectangle. Nice job. Okay, does everybody see why? We have the parallel sides proving parallelogram, and then we have the right angle proving rectangle. Nice job. Two, do we know for sure MPQR is a rhombus?
No.
No, why not?
Because it only has two of them.
All I have is two congruent sides. What else would I need to know to say it's a rhombus?
To see if they're intersecting.
I would have to know, I could know the intersections, okay? I could do some of the intersections. What else can I do? What if I told you these lines were now parallel? Now would that be a rhombus? Yeah. Now because I'm telling you the lines are parallel, it's a parallelogram, meaning it's a rhombus. So notice the difference there. You have to know it's a parallelogram first for some of these things to take place. Okay? We can also look at this in the coordinate plane. So for example, you can identify special parallelograms in the coordinate plane by examining their diagonals. If the diagonals are congruent. Alright, so if the diagonals are congruent, then it's a rectangle. If the diagonals are perpendicular, then it's a rhombus. And if the diagonals are congruent and perpendicular, that means it's going to be a square. So again, if you think about a rectangle, rectangles, my diagonals are congruent. In a rhombus, okay, these are 90 degrees. And then when I have a square, they are 90 degrees and they are congruent. All right, so we're looking at both these. So recognize these properties. let's look at these first set of problems when they come up. There we go. So here's an example. I have a diagram drawn, A, B, C, D, and I want to recognize what type of shape it is. So first thing I do is I find the distance. So using the distance formula, Pythagorean theorem, either one, I find the distance. Notice the distances are the same. So that means right away it's going to be a rectangle. Because they're the same, it tells me right away that's a rectangle.
Wait, what?
And then I'm going to look at the slopes. I have 4/5, -4/5. Are those perpendicular slopes? No, because they are not opposite reciprocals. So this one is just a rectangle. Okay, let's say this one, instead of being -4/5, it was -5/4. Now would that be a rhombus? Yes. Then, because it's a rectangle and a rhombus, now it's also a square. All right, so they both have to be met for it to be a square. One of them for rectangle or rhombus. All right, let's take a look at these here. It says, find the lengths and slopes of the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all names that apply. So notice it's E, F, G, H. So that's like saying, you know, I have a shape, something like this. E, F, G, H. So my diagonals would be E, G, and HF or FH. Does everybody understand that? The diagonals are not the ones next to each other. So as I look here, I want to find the distance and I want to find the slope. So E was -2, -4. G was -3, 1. F was 0, -1. And H was -5, -2. I would like you to take a couple seconds and find the distance and slope of those two coordinates. All right? Don't worry about doing number 4 yet. But take a couple seconds, work number 3 out, find the distance and slope of both those coordinates. What's the distance from E to G? Square root of 26 is correct. Yeah, when you do the distance formula, you get 5 and 1. 5 squared is 25. 1 squared is 1. 25 and 1 squared 26. Becca, what's the slope of EG?
-5.
Yeah, -5 or -5/1. Nice job. Claire, give me the distance for FH. Square root of 26. Nice. Claire, what's the slope of FH? 1/5. So I find the distance, I find the slope. Now I have to determine what it is. So as I look, Anderson, my distances, are they the same?
Yes.
So that means it's going to be a rectangle. Anderson, my slopes, are they opposite reciprocals? So that means it's going to be a rhombus. And if it's both a rectangle and a rhombus, that means it's also a square. Square, nice job. All right, let's try number 4 as well. Take a couple seconds, try number 4 as well. Again, find the diagonals. You have -1, 3, 0, 4. And the next one, you had -2, 5, and 1, 2. So take a couple seconds and try number 4 on your own. All right, number 4, Simeon, give me the distance for PR.
Is that the first one?
Yep,
Square root of 2.
the distance is square root of 2. Then I want the distance for QS. Jeremiah, do you have the distance for QS?
3 square root of 2.
Yep, we get square root of 18, which is 3 square root of 2. Are my distances the same? Nope. So it's not a rectangle. Simeon, back to you. Give me the slope of PR. Slope of PR was 1. No, wasn't it -1?
No, that's the other one.
Oh, the other one. This one's 1. Okay. Slope of QS, Jeremiah.
-1.
That one's -1. There we go. Are my slopes opposite reciprocals? Yes, which means it's going to be a rhombus. All right? Take a couple seconds, try these two on your own. Same idea. You want to do the diagonals. So I would want to do TC, and I would want to do EH. So TC is the coordinate 3, 0
Wait,
and 11, 4.
if the slope, if the distances are.
And then EH is the coordinate 6, 4 and 8, 0. And then same thing with number 6. I want to find the diagonal of ER, which is 1, 3 and 12, 0. Then I have ZA, which is 10, 6 and 3, negative 3. All right. Take a couple seconds to try these two on your own. Find the diagonal's distance and their slope. All right, Colton. Number 5. I want to find the distance from T to C. What's the distance from T to C, that diagonal? Square root of 80. What's the slope there, Colton? 1/2. All right, EH. What's the distance from EH, Colton? Isn't it square root of 20?
Yeah.
And then what's the slope there, Colton? So are my distances the same? Are my slopes opposite reciprocals?
Yes.
So Colton, what's it going to be? Rhombus.
It's a rhombus.
And 6, ER. Let's go with Jake O'Connor. Give me the distance there. What do you get for distance?
Square root of 130.
What's the slope of ER? Jake?
Negative 3/11.
Jake, then I have ZA. What's the distance from ZA?
Square root of 130.
Jake, what's the slope there?
9/7.
So Jake, are my distances the same?
Yeah.
So that means it's a rectangle. Are my slopes opposite reciprocals?
No.
No, so that means it's just a
Rectangle.
rectangle. Nice job. There's your answers. And here's your assignment.